Okay, this is part 2. So we're going to be looking at the rest of permutations in this video. So go ahead and be sure that you are at the end of where you left off with the first video on permutations, and we're going to start on this slide that says with repetition. Okay, we can use the fundamental counting principle on situations that have numbers and letters, etc., that are allowed to repeat, such as phone numbers or names. You can have repeated numbers in a phone number. You can have repeated letters in a name. We can use the fundamental counting principle there. You cannot use the fundamental counting principle when you are rearranging words that already have repetition in them. Okay, why not? Well, because if I have a word that has repetition in it, like the word peer, you see the word peer here on your slide, it has 2 E's in it. So if I use one of the letters, I don't know which one I took. So I don't know if it was the P or if it was the R or if I took one of the repeated E's. So I don't know really how many options are left if I have a word that is repeated. So you cannot use the fundamental counting principle when you're rearranging words that already have a repeated letter in them. Okay, let's consider the making of telephone numbers. Okay, so that's the first example that we're going to look at. Let's consider the making of telephone numbers. Is order important in making these arrangements? Why or why not? Okay. Is order important in a phone number? Yes, it is. Because if my phone number is 321-3232, if you dial 312-3232, you're not going to get my phone to ring. Can numbers repeat in a phone number? Yes, they can. My phone number at school is 321-3232. So the 3's and the 2's repeat. So how many different numbers could there be? Well, let's talk about area codes, because area codes are a little shorter than numbers and it won't make us do as much work. So how many different area codes are possible using the fundamental counting principle? Well, the first thing you need to know is that an area code has 3 numbers in it. 3 numbers in the area code. And the numbers that we can choose to put in those places are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We can put those numbers in the 3 places. However, an area code never starts with a 0. So in this first place, I can't put the 0, but I can put the other 9 numbers. So in the first space, I can put the 9 numbers. In the second place, I can put a 0 in the middle. So I could put all 10 of those numbers in the second place. And then since repetition is allowed in an area code, I could have 202, then all 10 numbers would be allowed here. The only one that's different is the first, because I'm not allowed to put a 0 in the first space in an area code. So now we're going to go to our calculator. We're going to do 9 times 10 times 10, and that's going to give us 900 area codes are possible. Let's look at example 6. How many permutations are possible? I'm just going to slide this over. How many permutations are possible from the word television? So television. Do any letters already repeat? I hope that you see that the E's repeat, the I's repeat. Are there any other letters that repeat? No, those are the only ones. So E's and I's repeat. So here what I would do on my in my notes is I would say yes, E and I. Repeat. How many letters total are there in the word television? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters total. How many E's are there? There are 2 E's. How many I's are there? There are 2 I's. So what we have to do here is we have to actually divide. So to find out how, we're going to use a formula here. Oops, except I didn't spell it right. Sorry, formula. Okay, we're going to use a formula here. We're going to take the number of letters total, that's 10, and we're going to say 10 factorial. And then we're going to divide that by the number of E's that there are. So there are 2 E's, so we're going to do 2 factorial. And the number of I's that there are. So we're going to do 2 factorial. So to evaluate this, you can do it one of 2 ways. You can say 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 2 times 1. 2 times 1 cancels. And this 2 right here will also divide into this 4 2 times. So then I can go to my calculator and do 10 times 9 times 8 times 7 times 6 times 5 times, not 4 anymore, but times 2, and then times the 3. And that gives me 907,200 ways. And this is with repetition. Or I could go to my calculator and type in the formula. Okay, so here's my calculator. I'm going to try to get it on the screen. And here's the formula that I'm going to be typing in. So we're going to do 10 factorial. Remember, it's math over to probability, number 4, divided by, now I'm going to remember that if I do this in the calculator all at one time, that I have to put the bottom factorials into parentheses, times 2 factorial, whoops, 4, close my parentheses, and I should get exactly the same number that I had before, 907,200 ways. Okay, so let's try another one together. How many permutations are possible from the word probability? So P-R-O-B-A-B-I-L-I-T-Y. Okay, so the first thing I want to know is how many letters? How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters. Okay. What letters repeat? So repeating letters. Let's see what letters repeat. Well, here's a B and here's a B. So there are 2 B's. There is an I here and an I here. So there are 2 I's. There's no other P, there's no other R, there's no other O, there's no other A, there's no other L, there's no other T, and there's no other Y. So the number of letters goes on top, so that's 11 factorial, divided by the number of B's, that's 2 factorial, and the number of I's, that's 2 factorial. So now let's type that into our calculator one more time. Let's look at the calculator so that we can make sure that we do this correctly. Okay, so this time I'm going to do 11 factorial, math over to probability number 4, divided by parentheses 2 factorial, math over to probability number 4, times 2 factorial, math over to probability number 4, close my parentheses, and that is going to give me 9,979,200 ways to rearrange probability when repetition is allowed. Now I want you to do the last one here. I want you to find the number of permutations for the word insidious. When you've done that, you're finished with this video, and we'll check it when you come to class.